Have you ever wondered how computers recognize edges in images? Well, it's not magic. It's all about the science of image processing, specifically the technique called the Laplacian of Gaussian edge detection. Firstly, let's unpack what that name means. The Laplacian of Gaussian is often abbreviated to log, and it combines two fundamental concepts in image processing: Gaussian smoothing and the Laplacian operator. The first step in the log technique is Gaussian smoothing. Imagine a noisy image full of unwanted details and specks. A Gaussian filter comes to the rescue, reducing this noise and slightly blurring the image. This smoothing process is crucial for the next step, as it reduces the likelihood of detecting false positives, or edges where there aren't any. Now, onto the second half of the name, the Laplacian operator. This operator is applied to the smoothed image from our first step. It works by computing the second derivative of the image, which is a fancy way of saying it detects areas where the intensity of the image changes rapidly. These areas of rapid intensity change correspond to edges. But how does the Laplacian operator highlight these edges? It finds what we call zero crossings in the image. These zero crossings are points where the intensity of the image changes from positive to negative, or vice versa. These points mark the locations of the edges in the image. So, to summarize, the Laplacian of Gaussian edge detection technique is a two-step process. It starts with Gaussian smoothing to reduce noise and blur the image slightly. Then, it applies the Laplacian operator to detect areas of rapid intensity change which correspond to edges. This technique is effective in detecting edges at various scales due to the combination of Gaussian smoothing and edge detection. It's a fascinating process, isn't it? The next time you look at a digital image, remember the complex calculations and techniques, like the Laplacian of Gaussian, working behind the scenes to create that clear, crisp picture.